Hello everyone, hope you are doing well. In this tutorial, we will discuss factor analysis. Factor analysis is a multivariate statistical technique which is used to reduce a large number of variables into a smaller number of underlying factor, or you can say on the basis of latent variables without losing much information. The main objective of factor analysis are to reduce number of variables, to identify latent factors, remove redundancy among variables, develop valid measurement scale, and prepare variables for further analysis. Before proceeding further, we will discuss some assumptions of factor analysis. The assumptions are variables should be continuous and correlated, sample size preferably at least 5 to 10 observations per variable should be there. There should be no extreme multicollinearity and data should approximately follow a normal distribution. To discuss factor analysis, we will discuss in detail the various components and tools of factor analysis like KMO test, Bartlett test, principal component analysis, rotation methods, Scree plot, and their interpretation. So, to perform factor analysis, we will first add data. I have added data of respondent on the basis of their perception regarding agricultural input by taking rainfall, irrigation, fertilizers, mechanization, seeds, soil fertility, labor, market access, education and credit variables. So to perform, go to the analyze, select the dimension reduction and click on factors. Insert all variables into variable box. Go to the descriptives. Select KMO and Bartlett anti-image. Click on continue. Again go to the extraction. Select covariance matrix and keep eigenvalue greater than 1. Press continue. Go to the rotation and select Varimax. Click on score and save as variables. Click on continue and press OK. These all tables indicate the factor analysis. Now the KMO and Bartlett test. KMO known as Kasser-Meyer-Olkin measure. It measures whether the data are suitable for factor analysis or not. KMO test indicate that whether we should proceed further or not. It compares the correlation between variables, and you can see in this example the correlation between variables is quite high and it is 0.911. If variables have high correlation, factor analysis is appropriate. So we will proceed for factor analysis. The range of KMO values lies from 0 to 1. Now the question arises, why KMO is so important? Because without significant and sufficient correlations among variables, factor analysis cannot identify common factor. Therefore, the KMO value should be greater than 0.6. Bartlett test of sparsity. Bartlett test examines whether variables are significantly correlated or not. It tests null hypothesis, and we consider null hypothesis for factor analysis as the correlation matrix is an identity matrix, means there is no correlation among the variables. On the other hand, we consider alternative hypothesis that variables are correlated. The output: chi-square value, degree of freedom and significance. For Bartlett test of sparsity, we analyze significance value. If the p-value is less than 0.05, we proceed with factor analysis. If p-value is more than 0.05, we do not perform factor analysis. Now the concept of principal component analysis. Principal component analysis is the most commonly used extraction method in SPSS factor analysis. Its objective is to convert many correlated variables into smaller number of uncorrelated components, and each component is weighted combination of the original variables. Total variance explained. These are the components and their eigenvalue. We consider the components whose eigenvalue is more than 1. In this example, only component 1 has eigenvalue more than 1 and its cumulative percentage is 88.93%. Scree plot. A Scree plot indicate component number on x-axis and eigenvalue on y-axis. How to interpret Scree plot? We retain the components before the point where the curve level off such that elbow. In this example, the curve flatten after component second, so we will keep only the first component. Suppose if the curve start flattening after the fifth component, in that case we will consider the first four component the component matrix. Component matrix shows the correlation between variables and components. These are my components and they are variables. Higher loading indicate a strong relationship between the variable and component. For example, in this case, the loading is very high. The rotated component matrix. In this example, only one component was extracted. To make it more clear, I am taking a hypothetical example. In this example, you can see the variable rainfall, irrigation and fertilizers fall within a single factor because their loading is high and suggesting an agricultural input factor. On the other hand, education and income load highly, representing a socio-economic factor in case of factor 2. And for factor 3, soil texture load highly, indicating a natural resource factor. In this manner, you can perform factor analysis. Thank you. Have a nice day.